the James Webb Space Telescope has fundamentally unveiled the most precise image of Proxima Centauri B to date, offering remarkable insights into a potentially habitable exoplanet. Invites us to embark on a journey through the cosmos to uncover the mysteries of Proxima Centauri B and determine if it could be the next Earth. We venture into the vastness of space, where a mysterious planet resides within the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. Its existence is extraordinary. Proxima Centauri B is located a mere 4.2 light-years away from us, making it the closest known exoplanet to Earth. This planet is shrouded in enigmas and marvels. Could it be another Earth with oceans and life flourishing on its surface? However, there's more to the story. Proxima Centauri B isn't solitary in its system. It has a companion, Proxima Centauri C, orbiting the red dwarf star. And who knows what other secrets the star system holds? Perhaps there's another companion yet to be discovered. The intrigue deepens. Proxima Centauri emits approximately the same amount of energy from its star as Earth does from the Sun. Could this truly imply that there's water on its surface and possibly even life? As we explore beyond our solar system, we encounter an entirely new realm of exoplanets, planets that orbit stars other than the Sun. With an estimated 200 billion stars in the universe, the possibilities for exoplanets are limitless. Some exoplanets even drift freely through space, unattached to any star, like wandering travelers in the cosmos. Among them all, Proxima Centauri B stands out as an especially captivating and intriguing planet. This year lasts only 11.2 Earth days, and its proximity to its star is closer than Earth's distance to the Sun. Indeed, one side of the planet is perpetually bathed in sunlight, while the opposite side remains in eternal darkness. Now let's delve into Proxima Centauri, the star that Proxima Centauri B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri B. Together, these stars form the closest star system to our solar system. The two stars Alpha Centauri A and Alpha Centauri B constitute a binary system known as Alpha Centauri AB. These G-type and K-type stars appear as a single entity in the Centaurus constellation and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also referred to as Alpha Centauri C, is a red dwarf type star located 4.2 light-years from the other two stars, approximately 4 times the distance between Earth and the Sun. It holds the distinction of being the closest star to us. The term Proxima means the closest in Latin, and it was discovered in 1915 by Scottish astronomer Robert Innes. Despite being our nearest celestial neighbor, Proxima Centauri is not visible to the naked eye, with an apparent magnitude of 11.13, much dimmer than the human eye's limit of 6.5. Nevertheless, don't let that deceive you. Proxima Centauri is still a star worth studying. Red dwarfs, like Proxima Centauri, are among the most efficient in terms of energy production. They may not emit a vast amount of energy, but the internal convection processes at their cores sustain them for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still a topic of debate. For one, it's a flare star, meaning it experiences frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 54 But it's not as habitable as it seems. Proxima Centauri b is bombarded by intense ultraviolet radiation from its star regularly, stronger than the radiation we receive from our sun. That's right. It's so extreme that even the lightest particles of hydrogen are stripped away along with nitrogen and oxygen. But that's not all. Just because the planet is at the right distance from its star doesn't mean it can support life. Proxima Centauri b may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, living organisms would be vulnerable to harsh space weather conditions, making life nearly impossible. So while Proxima Centauri b might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious as many factors render it inhospitable. The mission to reveal the truth about Proxima Centauri b continues. One tool that has garnered the attention of astronomers is the James Webb Space Telescope. After years of anticipation, the telescope was finally launched in 2018 and will assist in determining if there is life on Proxima Centauri b. However, as with everything in science, things are never as clear as they seem. Several adjustments were necessary to ensure the James Webb Space Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima Centauri b can absorb light from its star, it can also emit it as infrared light. The James Webb Space Telescope was specifically designed to detect infrared light, can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima Centauri b could be like Venus with a thick atmosphere that is significantly denser than Earth's and extreme temperatures. That would make it impossible for life to exist. The journey to unravel the mysteries of Proxima Centauri b is not without its challenges. While the James Webb Space Telescope holds promise, other factors must be considered. With costs mounting, space scientists feel the pressure to find ways to observe planets like Proxima Centauri b. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. The exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima Centauri b's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. However, the journey is anything but simple. For example, it would take approximately 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system at its current speed. Nonetheless, a potential solution has been proposed. Solar sails. The ultra-thin reflective sails could be employed to propel a spacecraft toward the Alpha Centauri system, including Proxima Centauri. This technology harnesses radiation pressure from sunlight to maintain its trajectory, eliminating the need for traditional fuel. Even more fascinating, advanced propulsion method could offer insights into the existence of life on distant worlds like Proxima Centauri b. However, like all bold ideas, there are limitations. For instance, simply having an atmosphere does not automatically equate to habitability. Proxima Centauri b could resemble Venus, cloaked in a thick, scorching atmosphere that renders the surface uninhabitable. James Webb Space Telescope has the capability to detect emissions even if they amount to only 5% of the brightness of the planet's day side. That may not sound like much, but considering the dim nature of its host star compared to our Sun, it's quite significant. Proxima Centauri b harbors advanced civilizations. They might even utilize enormous orbital mirrors to redirect sunlight from the perpetual day side to the dark side. How fascinating is that? The universe contains countless exoplanets awaiting discovery. The celestial bodies span an immense range of types and sizes from massive gas giants to Earth-like planets. Intriguing type of exoplanet is the gas giant, similar in composition to Jupiter and Saturn, but often much larger. Some are called superjupiters, dwarfing even the largest planets in our solar system. But that's not all. They're also hot Jupiters, massive gas planets that orbit extremely close to their host stars, residing in environments so hot they could melt metals. Picture witnessing such a planet up close with violent storms and searing temperatures. Addition to gas giants, there are Neptunian exoplanets which share similarities with Uranus and Neptune. Among these are hot Neptunes and mini Neptunes, smaller, closer inversions of their gas giant cousins. These planets are often cloaked in mystery due to the difficulty of analyzing their atmospheres from afar. Let's not overlook Earth-like exoplanets, worlds that closely resemble our own. The planets vary in size, ranging from slightly smaller than Earth to over twice its mass. Among them are super-Earths, which are more massive than our planet, but lighter than ice giants like Neptune. One of the most captivating exoplanets discovered in recent times is Proxima Centauri b, which revolves around the star of the same name. It is classified as a super-Earth with a mass estimated to be about 7 times that of Earth. Although it lies close to its star, it might still be too far to fall within the traditional boundaries of the habitable zone. And Proxima Centauri b isn't alone. It has a sibling Proxima Centauri c, which is situated farther out in the system. This planet completes one orbit roughly every 5 Earth years and was confirmed in 2020 using archival Hubble Space Telescope data. Even more intriguing is the suggestion that Proxima Centauri b may be an exceptionally luminous planet, potentially due to a ring system reflecting starlight. But the intrigue doesn't end there. In 2019, astronomers noted a peculiar variation in Proxima Centauri's radial velocity, potentially indicating the presence of yet another planet. If verified, this planet would be named Proxima Centauri d and is estimated to be about the size of Mercury or Mars. Imagine a night sky not only filled with stars, but with an abundance of alien worlds, each possessing unique properties, climates, and orbital patterns. The cosmos is a treasure trove of surprises, and exoplanets are among the most intriguing, with new exoplanet discoveries being made regularly. It's an exhilarating time to be a planetary scientist or astronomer. Although we don't yet know the exact number of exoplanets, it's clear that they are as abundant as the stars themselves. However, these distant worlds present significant challenges. They're often hidden by the brightness of their parent stars, making direct observation exceedingly difficult. Yet technological advances have now made it possible to directly image some exoplanets. To achieve this, A planet must be large enough, far enough from its star, and young and hot enough to glow in infrared. All very specific conditions that limit what we can observe. Even these few glimpses are profoundly enlightening. Most exoplanets are discovered not by direct observation, but by the effect they have on their stars. The gravitational tug of an orbiting planet can cause a star to wobble, a phenomenon known as radial velocity, which astronomers can detect. NASA's Kepler Space Telescope revolutionized this field using the transit method, detecting small dips in starlight as planets pass in front of their stars. This method has given us valuable data on planetary sizes, orbital distances, and surface temperatures. Here are a couple of intriguing facts. Over 22% of Sun-like stars are believed to host Earth-sized planets in their habitable zones. The TRAPPIST-1 system boasts 7 rocky planets, several of which may contain liquid water. Just like the moons in our solar system, many exoplanets are likely to have natural satellites, exomoons. With over 4,000 exoplanets confirmed so far, we know they are widespread throughout the galaxy. Hot Jupiters, with their immense mass and close proximity to their stars, remain the easiest to detect, but thousands of other planet types await discovery. NASA's James Webb Space Telescope is at the forefront of these efforts, unveiling cosmic secrets with each passing day. This incredible observatory continues to gather detailed data and stunning imagery, shedding light on phenomena we previously could only theorize about. Recently, it made a groundbreaking discovery: the first clear detection of carbon dioxide in an exoplanet's atmosphere. This planet orbits a sun-like star 700 light-years from Earth, and the discovery provides vital clues about its chemical makeup and evolution. It marks a major milestone in our quest to find extraterrestrial life. Administrator Bill Nelson emphasized that this finding offers an entirely new view of the universe, igniting excitement among the global scientific community. And there's more. The James Webb Space Telescope has captured spectacular infrared images of the cosmos. In one case, it observed the object known as 110 IRS-4, which illuminates a cloud of cool, wispy material. Behind it, orange hues mark the glow of distant stars hidden behind layers of ice and dust. This research is part of the Ice Age Initiative, investigation into how ice forms in space, from interstellar grains to icy comets. Additionally, the telescope has, for the first time, imaged the structure of a dusty disk around a nearby red dwarf star in the infrared spectrum.